Mhm. Yeah. Yes. Welcome back, and we can start presentation. Mm, From our previous class, we looked at cabbage, and today we want to see on tomato diseases. Actually, from our previous class, we knew that some diseases affect plants, and these diseases, if not protect or taken action before it affect the crop, meaning the production of this crop will reduce or decline. So today we want to see the diseases that affect tomatoes, and these diseases maybe you can know how to deal with it or prevent it before it attacks the crop itself. So there are different types of diseases that affect the tomato studies. There's bacterial wilt, there's prosomandroid, and there's blight. Actually, today we want to see the bacterial blight. This bacterial blight, we can find that this disease that is caused by a pathogen, and this pathogen, we find that it enters into the plant and affect the crop itself. So let's start the brief introduction of this disease that is bacterial wilt. We find that bacterial wilt is a sort-borne disease, and this disease affect the Solanaceae family. The Solanaceae families, these are crops that like the cabbage, or there's tomatoes and so on. And this disease actually, it affects when the temperature is too high, that is above 85 degrees Celsius, and the most soils. I find that this disease enters into plant through a microscopic wounds, and these microscopic wounds can be either than maybe it is these are wounds that are found in the plant itself. Maybe the farmer was cultivating or transplanting these plants, so it causes injury to the plant, meaning this pathogen will use this going to do what, to enter into the plant, and this plant, if it is affected by this bacterium, it will start the wilt. So we find that this bacterial wilts affect the vascular tissue. The vascular tissues, from our knowledge of biology, we know that this enters the phloem and the xylem tissue. And if you tamper with the phloem and the xylem tissue, meaning you do what, you will affect the transportation system within the plant, that is a transportation of water and manufactured food from leaves to all parts of the body of the plant, maybe from the roots to the branches, maybe. So we find that if it this bacteria croaks the phloem tissue or the xylem tissue, meaning the plant will eventually die because the manufactured food has not reached to the destination. Actually, what are the symptoms of this disease? Maybe if you want to see, if you want to know that the plant has been affected by this bacterial wilt, we find that at the initial stages, that is when the plant is young, the green or the youngest leaves start to wilt. At the same time, the plant still can be appear green, but eventually that's what turns dark. And as the disease progresses, we find that the base of the plant may show brown fungus, root rot, and the cross section is affected by maybe that is the brown discoloration of the vascular tissue. The plant may appear wilted in the afternoon and seem to recover overnight. That is to gain moisture. Maybe this is due to less water needed in the morning when there's high humidity. But at the same time, we find that as the heat increases, the crop, that is the vascular bundles, vascular system limits the uptake of water and the transportation of manufactured food from plants, from the leaves to the plants of the parts of the plant actually, and eventually this will become permanent. And if it's become permanent, meaning there's no transportation of these materials from one plant to one point to another, meaning the plant with that will eventually die. So how do you control this disease? As you know that from the start we look at how the disease gets into the plant itself. Meaning it uses the grown studies, the microscopic grown study I found within the plant, meaning how do we control this disease before it affects the plant itself or before it attacks the crop. So from our previous classes, we have learned that if we control or we take action before the plant is affected, meaning the production will do what? Will increase rather than decreasing. So what about the control now? How do we control this disease? We find that bacterial wilt is difficult to control or manage once it's present in the field. If you allow the crops to be attacked by this disease, meaning it will be difficult to control it, meaning you should do the safety measures or control this disease or control the entry of disease into the farm at the early stages before it affects the crop. So there are some cultural practices, that's mechanical practices that may prevent the disease in incidence in the plantation. We have this culture. Culture is the thing that we do naturally. Maybe use at a crop to do what? To prevent certain crops diseases. For example, you can take crop rotation. Yeah, at the same time, if you practice crop rotation, meaning if the previous crops that were attacked by bacterial wilt were in the field, meaning if you do crop rotation, meaning these initial crops that is being planted in the same field will not be affected by bacterial wilt. So if you do crop rotation, meaning the less attack of the bacterial wilt in the initial plants within the farm. Actually, what about if you identified this crop, if the bacterial wilt has affected one crop, meaning you identify it and remove it from other field, maybe to prevent the spread to other plants, maybe. So if you identify one plant, maybe you remove it, meaning you do what? You prevent this crop from doing what? From spreading to other plants. We can use the other field, like you can use different types. Maybe you want to use bacterial, if you want to control this bacterial wilt, as I told you that you can't control this crop while in the field, meaning you can control it before it gets into the field, because it's difficult to control the disease. Meaning if you practice this maybe crop rotation, planting cover crops, that is unsuspected, that is like the corns, the beans, and the cabbage. You can eventually do what? You can eventually prevent this disease from attacking crops. What about when you use the resistant rootstock, that is grafting? Grafting, we find that the modern technology has introduced a grafting method that is use different rootstock and different science in doing what? In plant propagation. So if the rootstock is highly resistant to this crop, as a farmer, you're advised to do what? To use this rootstock so that you can do what? You can prevent this bacterial wilt. There's some various bacterial wilt resistant rootstocks. Maybe you can use this rootstock to do what? To prevent this disease. Like for example, we have the RST 05113T. This is one of the resistant rootstock that helps to you, a farmer, to identify or to prevent this disease from entering the farm. At the same time, there's a Boma, there's a Jinshong, there's what? There's Amanda. Actually, from there we can see that we can able to gun this bacterial weight down, because the control measures are decided to you that this bacterial weight enters into the plant by use of what? By use of the microscopic cones within the plant. So as a farmer, you should avoid making injuring your plant. And as you know that this injury is caused to the plant, it is the bacterial will, or this disease will get entry into the plant using this entry, this wound. Actually, at the same time, you can use the resistant rootstock, and finally, you can use what? You can use resistant rootstock and cultural means. Actually, I think that is the end of today's presentation. And next presentation, we can see how Prosum end rot can be controlled in your farm. So as a farmer, you should know how to control these diseases for you to attain maximum production of your products, meaning safety measures before. As I told you that before the disease enters into a farm, meaning you should control it before it enters or it affects your crops. So as a farmer, you are advised to go or to practice various agricultural practices that enables you to prevent or to keep your plants healthy. So I think our next class or our previous presentation will be able to know how to deal with these crops diseases actually. Thank you, and I think we can end our presentation there.